Section 11.1.33. A physical therapist wants to determine the difference in the proportion of men and women who participate in regular sustained physical activity. What sample size should be obtained if she wishes the estimate to be within 2 percentage points with 95% confidence? Assuming that in part A, it says she uses the estimate of 23.1% male and 20.5% female from a previous year. To find the sample size required to obtain 1 minus alpha times 100% confidence interval with a margin of error E when prior estimates of P1, P2, point estimate 1, and point estimate 2 are available, we're going to use the following formula. Okay, so this is the formula to find n, because what we're looking for is we're trying to find the sample size. So in this particular problem, we're looking for the sample size because that's what it's asking, and that means that we're looking for n. So what do we need to know? Well, we know a few different things here. We're going to start by identifying the values of the variables in the formula and expressing them as decimals. So let's take a look at the first one. So the first one we have is point estimate number 1. Okay, point estimate number 1 in our question is a percent, which is 23.1%. And then we're going to write that as a decimal, so we're going to move it to the left twice. So we're going to get 0.231. Okay, and then we have point estimate 2, and that is a percentage of 20.5%, and then converting that to a decimal is 0.205. Okay, now what else do we need to know? Well, we need to know what is the margin of error. Well, the error is given as 2 percentage points. So it says it's within 2 percentage points. So that means E is going to equal 2%. And then we're also going to convert that to a decimal, which is 0.02. Okay? Now that we have that, now we need to determine what is the critical value. So how do we find the critical value? Well, recall here that the critical value is given by the 95%. So if we want to find the critical value, we know that alpha is going to equal 1 minus 0.95, which gives us 0.05. Okay, and then we need to take alpha and we need to divide that by 2. So if we take 0.05 and then divide that by 2, then that's going to give us 0.025. Okay, now just so that we are clear on how to find the critical value, and the critical value that we're looking for is z.025. What that means is if we had a bell curve, okay, and here is our mean, and then our critical value is located right here, z, which is 0.025. So that means the area here is 0.025. And then over on this side is going to be 1 minus 0.025. Well, that's equal to 0.975. So if we want to find that critical value, then what we're going to end up doing is we're going to find that critical value using Inv Norm, where we have the area to be to the left of that critical value of 0.975. We know our mean is 1 and our standard deviation is 0. So let's go ahead and do that. So let's pull up the calculator here. All right, so we're going to go to second distribution, scroll down to Inv Norm, and then we have 0.975, and then mean is 1, standard deviation 0, mean is 0, standard deviation is 1, and then we're going to paste, and then we're going to get the following. So we're going to get this value here, and that's going to give us the critical value. Okay. So now that we have that answer, now let's round it to 2 decimal places. So this is rounded to 1.96. So now we can actually find the sample size. And the way we can do that is now plug in everything that we have, because we have everything that we need to be able to solve. So let's go ahead and do that. So we have n, which is equal to, we have bracket, point estimate 1 is 0.231 times 1 minus 0.231 plus point estimate 2, which is 0.205 times 1 minus 0.205. And then once we have that, we're going to multiply it by the critical value, which is 1.96, divided by the margin of error, which is 0.02, and then we're going to square it. Okay, so let's go ahead and do that on our calculator to find out what n is. So we're first going to go ahead and do order of operations. So we can go ahead and do what's inside the brackets. So we have 0.231 times 1 minus 0.231. Enter. And then we're going to add 0.205 times 1 minus 0.205. And then hit enter. And now we're going to multiply that by, we have 1.96 in the numerator divided by 0.02, and we're going to square that. And so therefore this is going to give us this particular value here. Okay, so now what we want to do is we are going to round up, regardless of whatever this decimal is, whether it's below 5 or above 5. We have to round up. So when we round up, we're going to round up and we're going to get the sample size to be 3,272. Okay, so now what we're going to do is we're now going to be able to now find the sample size when she does not use any prior estimates. Okay, so if there aren't any prior estimates, then to find the sample size required to obtain a 1 minus alpha times 100% confidence interval with a margin of error E, when prior estimates of the following are unavailable. So we don't have that in question B. In question A, we're given the point estimates. In this scenario, when they're not given, then you got to use this formula here. And in this formula here, what we need to know is the critical value and the margin of error. But we already have that information from the previous part. So we know that the critical value in this case was 0.05, gave us a critical value of positive 1.96. And then we also know that the margin of error was at 2%, and we convert that to 0.02. Okay, so now what we want to do is we now want to be able to find the sample size in this scenario. So n is going to equal 0.5 times the critical value of 1.96 divided by 0.02 squared. So let's go ahead and do that on our calculator. So we got 0.5, and then we're going to multiply that by parentheses 1.96 divided by 0.02 squared. And it's going to give us the following result. So there's no decimal there, and we don't need to round up, so we get 4,802 as the sample size.